Hey guys, I'm Miuccamatics and welcome back to my YouTube channel Miuccamatics. If you like math related videos, do subscribe and hit the bell icon so that you don't miss any of my videos. Today I'll be doing the course of analysis, under which I'll be doing the chapter infinite series. Let xn be a real sequence in summation n ranging from 1 to infinity of xn, which is equal to x1 plus x2 plus x3 plus dot dot dot, is called infinite series or infinite sum. Basically the sum of xn which continues up till infinity. Now partial sum, for any natural number n, the finite sum Sn equal to x1 plus x2 plus dot 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 plus xn is called as partial sum or sequence of partial sums. Basically it is the infinite series but limited to certain finite elements. So from x1, x2 until xn, so it is n number of elements. So it's finite. Now if the sequence of partial sum is convergent, then the infinite series is convergent. So basically if you notice, it converges, the sequence of partial sum. If it continues up till infinity, then the infinite series will converge. And if Sn, which is basically sequence of partial sum, if it diverges, then definitely the infinite series will diverge. Now this is an example. This is summation n ranging from 1 to infinity of 1. So basically this is just 1 plus 1 plus 1 infinitely many times. So the sequence xn is basically 1 over here for all n belong to the set of natural numbers. Now we take the sequence of partial sum. Sn is the sum of the first n terms. So s1, in this case it's only the first element, so it's directly 1. s2 is the sum of the first two elements. So it's 1 plus 1, which is 2, and so on. So S3 will be sum of the first three elements, which will be 1 plus 1 plus 1, which will be 3. So in general, Sn is the sum of the first n elements, and since all the elements are 1, it is 1 repeated n times, which is basically n. Now we want to check whether the sequence of partial sum diverges or converges. So we take the limit n tending to infinity of Sn, which is basically limit n tending to infinity of n. Now we know n is a divergent sequence, hence this limit diverges to infinity. Therefore the partial sum is divergent, hence the infinite series is divergent. Another example, this is summation n ranging from 1 to infinity of n. So basically it is the sum of natural numbers. So it's 1 plus 2 plus 3 plus 4 plus dot dot dot, it continues. The sequence is xn equal to n for all n belong to the set of natural numbers. Now the partial sum, s1, which is the first element, which is directly 1. s2 is basically sum of the first two elements, which is 1 plus 2, which is 3. s3 is the sum of the first three elements, 1 plus 2 plus 3. So in general, Sn is the sum of the first n elements, which is 1 plus 2 plus 3 plus dot 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 plus n. And as I showed in another video, it is basically n into n plus 1 by 2. And now if we take the limit n tending to infinity of Sn, which is basically limit n tending to infinity of n into n plus 1 by 2. Now we know that this limit diverges to infinity. As n diverges, n plus 1 also diverges. Hence the product diverges to infinity. Another example, summation n ranging from 1 to infinity of 1 upon 2 whole raised to n. The sequence xn is 1 upon 2 whole raised to n. Now Sn is the sum of the first n elements. So it is 1 upon 2 raised to 1 plus 1 upon 2 raised to 2, so and so on. So it's basically half plus 1 by 4 plus 1 by 8 plus dot 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 plus 1 upon 2 raised to n. Basically 1 raised to n is 1 upon 2 raised to n. So the sum of the first n elements. Now this is a geometric progression with common ratio of half. And as I showed in another video, the formula is basically a into 1 minus r raised to n upon 1 minus r. The first element is half, so half into 1 minus common ratio half raised to n upon 1 minus half, which is basically this half and 1 minus half, which is also half, cancels off to give you 1 minus half raised to n. Now we take the limit n tending to infinity of Sn, which is basically limit n tending to infinity of 1 minus half raised to n. Now this limit is limit n tending to infinity 1 minus 1 raised to n upon 2 raised to n. As I told you, limit n tending to infinity, it is 1 minus 1 upon 2 raised to n. Now as n tends to infinity, 2 raised to n also tends to infinity. So it is 1 minus 1 upon infinity, which is 1 minus 0, which is 1. So since Sn converges, hence the infinite series converges. Another example, summation n ranging from 1 to infinity minus 1 raised to n. Now the sequence xn is minus 1 raised to n. S1 is basically minus 1 raised to 1, which is minus 1. S2 is minus 1 raised to 1 plus minus 1 raised to 2. So it is minus 1 plus 1, which will be 0. S3 is minus 1 plus 1 minus 1, which is basically minus 1. So Sn in general is minus 1 plus 1 minus 1 plus 1 and so on plus minus 1 raised to n. This is again a geometric progression with common ratio minus 1. So it is a into 1 minus r raised to n upon 1 minus r. First element minus 1 times 1 minus common ratio minus 1 raised to n upon 1 plus 1, which is 1 minus of minus 1. This is basically is minus 1 upon 2 into 1 minus minus 1 raised to n. Now basically if we take the limit n tending to infinity of Sn, which is limit n tending to infinity of minus half into 1 minus minus 1 raised to n. Now if you notice, Sn will take only two values, which is either 0 when n is even or minus 1 when n is odd, as in this example. So over here 1 is odd, hence the sum is minus 1. When it is even, they cancel off, giving you 0. When it's odd again, we add another minus 1 to it, so hence it comes minus 1. Now here we see that Sn converges to 2 points. The convergent sequence converges to a unique limit, not in this case, hence it is divergent, and hence infinite series is divergent.